Hello everyone, we are back with more Ethereum updates. This week we have a lot of stuff. We have the Reddit AMA from the Ethereum Foundation and very interesting research articles from Barnabé, Anders, and Preston Evans, Sovereign Labs. So let's go through it. Let's start with the AMA. So there is a lot of stuff. This actually was super interesting, and I've put together some of the answers. And yeah, let's start with this statement from Dankred on DA capacity. Very, very clear. Last time we have seen the roadmap, and the roadmap is super useful. You can always look at it and make sure that you understand everything, or if something is not clear, it's a nice thing to start looking into. But here, I guess we also look more in detail at what is higher priority, or at least from the perspectives of different researchers in the EF. So Dankert said very, very clearly, extending Ethereum's DA capacity is definitely the most critical thing on our mind in 2024 and 2025. So, IAP 4844 is coming, and full dank sharding will take some more time next. But yeah, that's a very clear statement I like. Next, we have Vitalik on gas limits. So you might have heard people discussing about should we increase the gas limits potentially of Ethereum layer one? Why not? Should we start maybe increasing the throughput? Is it time? Moore's law and so on. You can see it said it also here. The thing is, um, yeah. I don't think the Moore's law is the limit here, or the reason why we should pump it. We could have increased the gas limit already in the past. I fully agree with that. But there is a thing that increasing the gas limit doesn't mean just increasing hardware requirements. So that's a potential concern that you don't want to cut off people who need to run or lower hardware requirements. But it's always the concern about state growth. So, increasing the gas limit, first of all, means accelerating state growth. And until we really fix that, you can imagine why there are concerns here, even for a modest increase in gas limit. It's not that easy. But, you know, that's definitely an interesting statement. And Vitalik thinks that at least a modest gas limit today might be reasonable. So there is that. Next, talking about other important things, what is higher priority in the roadmap. We know Ethereum has a rollup-centric roadmap since years. We know that. It's very, very clear. And we had a lot of progress, of course. We're not yet at stage 2, decentralized, secure rollups and everything. And also, there is a concern about composability. And as Ethereum rollup users, you know that. We have lost, as Justin puts it here, we have lost universal synchronous composability across Ethereum contracts, a fundamental driver of network effects. So on layer 1, you have full composability on all the smart contracts, which is nice, but you have lost that when we move to different rollup ecosystems. Now, the good news is that this is a temporary transition and we are in a preliminary phase. And most importantly, what's coming and what we need to build is shared sequencing with credible neutrality, high security, and pre-confirmations, and real-time snark proving. So this is definitely another important thing to really realize this roadmap, and it's clear that there is priority here. Next, parallelized EVM. Again, just Drake. And we can imagine, we can expect, actually, it already is a narrative for this year. And there is a trend on improving the EVM in general. So EVM has a lot of let's say, it has been proven over the years to be viable as a virtual machine. There is a lot of experience, there is a lot of mature tooling, there are a lot of developers, all nice things. But there is also now a question on how to improve it in general. And the thing is, a very nice thing also of this rollup centric roadmap is experimentation. So instead of improving the EVM directly on Ethereum layer 1, you first experiment on rollups. So this is nice statement, and it's very clear. And Justin believes that existing rollup can have the opportunity to improve the EVM, and Arbitrum and Optimism have already been doing. But then there's also a statement on other projects like Monad to build. Monad is working on parallelized EVM, and there is a question: should it be a layer one, or is it maybe a better opportunity, if not obvious, as written here, to build it as a rollup? So yeah, here Justin shared this message that he sent to CEO of Monad, Kyun, and I also noticed this is quite interesting. He said he's extremely impressive. It's not really a secret, but if you don't know now, it's not just impressive, but extremely impressive. And I think Justin uses words with a reason. Anyway, what was I saying? Yeah, the point here is that if Monad pivots to build a rollup on Ethereum, they could have the whole Ethereum community cheering for them at every step of the way. And yeah, I fully believe that. It could be huge if they build like a fully aligned Ethereum rollup, let's say. But anyway, let's move on. And we have again Justin on proof of stake economic efficiency. And there is this concept of, economic efficiency. How is it defined? Basically, is the ratio of the security budget by economic security. So this is the security budget is how much you pay for security, and the idea is to not overpay for security. And the security means how much is needed to actually attack the network. So we have an interesting statement again here, where Justin can confidently say that the EF researchers have achieved rough consensus that stake capping is desirable, and expect the EIPs and more discussion soon. So yeah, I guess this is coming, stake capping, and yeah, we actually have more stuff to talk about in these updates about that, or at least related to that, staking efficiency and issuance. So yeah. Next, this nice post again in the AMA from EF, Mike on different rollups configurations and economic effects on ETH. The question here was like how the fact that more activity is on rollups or moves to rollups, how is this affecting Ether, the asset? And there is not an obvious question, also because rollups can be built in different ways, or they can influence Ether in different ways. So that's why I like this post. Mike makes two very clear scenarios for two different rollups, and the question is which one is has more of an impact on Ether. So we have the first scenario where, yes, you have a new big layer 2 that gains a lot of adoption, and what this rollup does, or anyway this layer 2 does, is that it's posting its data to Ethereum through blobs and use Ethereum as the settlement layer. So it's an actual rollup. Like, we can all agree it's a rollup. It's not only using Ethereum as settlement layer, but it's also posting these data blobs. So yeah, it's a rollup. But then there is a there is a twist. Now imagine that this full rollup also has its own native asset used as gas. So instead of using Ether as gas, has its own native token used for gas. So it's not like there is some weird thing that in the background you swap the token for Ether, and no, you use that native asset for gas. I'll tell you more. Users don't even need to touch Ethereum, because this layer 2 is so big, as I said, it's gaining mass adoption in this scenario by Mike, and basically users don't even need to use ETH at all. They will be onboarded directly on L2. They go to an exchange, they buy this gas token, and they operate there. So that's the scenario 1, the rollup scenario 1. Full rollup, but not using Ether as gas. Then there is another rollup, scenario 2, and this one is still using Ethereum as the settlement layer, but it doesn't use Ethereum for blobs or for data publication. All right. This, yeah, it's an L2, but it's not really a rollup, or anyway, you can debate about that. This usually, fully agree, called the Validium. So now you have this rollup that is not using Ethereum for DA, or at least it's not paying Ethereum for data publication. Um, this seems less good, or sorry, this is worse for Ether because you're not using and burning Ether. But even now, and you know that data publication is more expensive or requires more Ether than just selling on Ethereum if you're a rollup. But even here, there is a twist. So imagine that in this case, Ether is the unit of gas on the chain. So that's different from the first scenario. So which one is better? And yeah, I think it's interesting that in Mike's opinion, scenario 2, the second rollup, so Validium using Ether as gas, seems better for the network effects and Lindy of Ethereum. I think it's very interesting, and I also agree with that. By the way, I think it's very, very important for Ether to be just accepted as money, and settlement is obviously taking less fees, but the fact that Ether is used as gas token and is accepted as money, like unit of account in the different rollups and medium of exchange in the different rollups, is more important than being used for data publication. Of course, I actually don't know that. I don't have data, and we will need to see what happens and which scenarios actually develop. But that's my feeling. Let's put it this way. So next, restaking semantics. Very nice. This is the second article in a series by Barnabé. The first article was on liquid staking, and the idea here is to define ways to really to define the semantics of these objects when you have an asset, a staked asset, a liquid staked asset, restaked asset, and everything that will happen. We know it's coming. So the idea here is to make it more clear, or at least have clear semantics, clear rules on how to identify or anyway describe the balance sheets of the different entities in protocol and out of protocol. It can become a mess. So I think it's a really good idea, and I really like the way he describes these things. It makes a lot of sense to me, and I guess it's the best to just write it down what are assets and liabilities of the different entities in the protocol. So I would really suggest you to read this blog post. It's the best way. They're very well explained. They go step by step. And I've put together here some notation. That's a big part of the post, is to have formal notation and semantics on restaked assets, how actively validated services are play a role here, and yeah, the best way is to actually go through it. So you see in this post you will find this kind of balance sheets, for instance, and they allow you to describe what actually happens when you restake an asset, starting from, well, in this case we have this solo operator stake ETH, for instance, a solo restaker that deposits in an eigenpod, and then from the eigenpod to the AVS. And it's always good, to have an idea of what the Ethereum protocol actually knows. You see, there is this article also from Barnabé that is always cited because it's very good, like to see like a protocol, and what the protocol sees, what is the reach of the protocol, what the protocol can influence, what happens out of the protocol. It's very good to have these kind of models. So yeah, I will invite you to go through it because it's the best way. You have to go step by step, and he helps you a lot on this. And you'll find also answers to what happens if there is slashing on AVS. That's the question that we all have. Like what actually happens, what the AVS will actually do. There are different scenarios possible, and having this kind of structured way to put down assets and liabilities helps a lot, especially when you go through even more complicated things, when you restake the same asset on different chains through the same operator in this case. But yeah, um, all the different cases can be put down this way, and you will always have a better idea of how things are moving, all these different claims. All right, next, effects of ETH issuance on Ethereum's equilibrium staking conditions. The second thread in a series by Anders. The first was on minimum viable issuance. Super nice. It took a while for me to go back to the minimum viable issuance thread. Unfortunately, I didn't have time at first. It was in my bookmarks, so I finally went through it, and it was worth it. So again, fully recommend. Read both the threads, and they're also posted as papers. And the goal here is to talk about how the issuance affects staking and vice versa. So thinking about different issuance curves, the parameters of the issuance and the different components of the yield, how they affect total stake. There is a lot to talk about, and this was amazing to read, honestly. And again, I fully recommend to go through it. I put together here also some important notation. So, in case you find already a picture that is very interesting to you and you just want to know what the different symbols are, you can also look at this. So we have things like the base reward factor, that is a parameter to define the issuance. Then we have the deposit size D, that is the total amount of ETH that is staked by everyone, and the ratio, that is relative value, burn rate, the REV, that is the realized MEV in a year, V, and then we have yield and supply curve, the supply curve and the different components of yield coming from issuance, coming just from attestation without proposing blocks, and the yield from REV. So yeah, this was the first thread. Definitely still worth reading. It's still very, 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 very interesting. And here, for instance, we had this concept of minimum viable issuance. That means, again, we don't want to overpay for security. So this is in the field where issuance is a cost to for the network, and you're basically inflating the token, and this is a cost for the network, and you want to minimize this to the minimum possible. Basically, you want to have just enough economic security, and you want your network to have good economic efficiency. It was we talked about this definition at the beginning. So there is that. What is the minimum viable issuance? How we can calculate it? How we can define it? And this thread was all about that. Here you can see, for instance, in this plot, you have two possible issuance curves. So there is a dependence here between the total amount of staked ETH, is this D on the x-axis, and on the y-axis you have both the yield, that is the current issuance policy, and the supply curve, that this is actually not really, like we cannot know it. It's unknown, but it's basically telling you how much the supply is increasing depending, what it's telling you, sorry. What it's telling you is that if you're at this point, basically you will have this amount of staked ETH available, this amount of ETH willing to be staked. That's basically what it is. So we have the issuance policy today, and you have a supply curve, and the intersection tells you where we are. Now, if you halve the issuance with basically, for instance, decreasing by half the base factor, then the intersection is here, because the supply curve is the same, and yield goes down, and the amount of staked ETH goes down. So you are decreasing the issuance, you are decreasing also the economic security. The question is this above the minimum viable issuance? Is this good enough? And you can go through, you should go actually through the thread. And let's move to the new thread. And basically it's part 2. It goes more in depth on certain aspects. And on this plot, for instance, we have these two blue lines, dashed lines. This is again the same plot as before for what concerns the axis. So we have on the x-axis the total amount of staked ETH, on the y-axis we have the yield, and we have these two limits. And here the idea is that we want to be somewhere in between these two lines. Why? This is the total amount of staked ETH at the time of the merge. So we want to be at least at that amount of staked ETH, not less than that. And this instead is the amount of ETH that corresponds to the number of validators that we know that would create, after that, it will start to create problems to the peer-to-peer network. So too much stress, too many messages. It's just things start slowing down or breaking down. So danger zone, let's put it this way. Unless, of course, we have other upgrades, increase max effective balance, you know. So, but for now, we want to be here, somewhere here. And what we know is the current issuance curve, that is F equals 64, that you have here, this white line. But you can also imagine, of course, other issuance curves that are obtained just by reducing the base factor. So we have this 48, 32, 16, or even 0. Now, what is not really known is the supply curve. So there is certain elasticity of the supply curve to the yield, and you can imagine that this supply curve can change over time. If staking becomes more accepted or the perceived risk of staking goes down, then also this supply curve can go down over time. So, we don't know precisely where we are at in this relationship, but this tool and this plot is telling you that the interception of supply and demand, you will get the equilibrium point. Okay. Next, there are many plots, and there is a lot of interesting stuff. So I really invite you to go through. But one that was really interesting to me was the impact on solo staker yield variability that you see here. So you have here again D and Y, same axis. There are more, so I don't want. It could have been much more confusing. So we keep it this way. And the color map here is YA divided by Y, and YA is the yield for the attestation, and Y is the total yield. So, this is telling you how important the yield from attestation is compared to the total yield. And, yellow means higher. What does it mean? If you're a solo staker, you rely mostly on attestations for the yield, because you will not get many block proposals, and also you cannot rely that much on REV because there is a lot of variability. If you propose blocks every once in a while, you will not be anywhere close to the average REV. So yeah, you would lose that. So the thing here is that if we want to have an issuance curve that is good for solo stakers, we want to be closer to the yellow zone, because then we are favoring basically attestations. Attestations are a big part of the yield. And again, you will see this kind of lines to know how to navigate this plot. You have the different base factors in white and different supply curves. You can see the interceptions in different places here and have an idea of how much yield you will get at how much staked supply depending on the issuance curve. And there is also another issuance curve that is completely different. There is this one in red, and you will also see the intersections with the supply curves. And this was proposed by Vitalik at some point. So there is also that, and you can see the issuance going down to basically negative after some point. So this is somewhere something related to stake capping, and yeah. Next, yes, you can see the solo staker yield variability also in this kind of plot. It's much more clear what happens if you reduce the base factor, the base reward factor, which is something you would do if you want to, reduce the issuance. If you do that and you also want to take care of solo stakers, you might want to know exactly how the variability is changing. So you have a probability function here, and basically the more is steep, the better it is in terms of variability, because you have less likelihood to be in unfavorable positions using negative here. And yeah, this is the thing. So if you want to reduce the issuance at some point with f equals 16, for instance, um, there will be a lot of variability for solo stakers. So there is that. And this, again, this is just a small part of the whole paper. It's very nice. Again, read it. And we'll conclude this part with one of the last plots that was shown. So we have seen issuance curves like this, where you see this is the standard issuance curve that you have, where the supply, I mean the yield or the total amount of issued ETH increases with the square root of D, is the total amount of staked ETH. And then we have another case in green where you just reduce the base factor from 64 to 32. In the paper, there are arguments for issuance curves that have a different shape, and you can see things like this yellow, this orange, and the pink curve, which have a higher issuance for small amounts of D than the 32 issuance curve, but then they go down or they're more stable. And yeah, there are of course, I mean, Anders makes very, very good arguments, and you will find the math there and everything, and why exactly this makes sense. But yeah, let's move on for now. I hope you will find time and to actually read the whole thread. Yeah, the last topic I have today is nearly optimal state Merkelization. This is a post that was posted on the Sovereign Labs blog by Preston Evans, and this was very, very interesting to me because it addresses one of the most important problems regarding scalability, that is, have a solution to state growth. And state growth is a problem, and it's actually limiting how much we can scale these systems, or how much we can increase the throughput. It's not just increasing the gas limits, but you also have to take care of state growth. And basically, if you Merkelize the state, the depth of the Merkle tree will increase over time, and basically any operation that touches the state will require a lot of random reads on the disk. It takes a lot of time and resources, actually. It can become the most important thing, and that's why you don't want to touch storage. Now, you can ask yourself, why do we want to Merkelize the state when there are other solutions where you have the state in a flat configuration, like linear, and you don't need to go through the whole Merkle tree? Well, we need that if we care about like clients, and we care about like clients if we care about verifiability. So, it's actually very, very important, and it's almost philosophical. And no, not philosophical, it's a true important thing, that there is like potentially what we're doing makes sense only if verifiability is there, And I think honestly, pretty much everyone agrees on this, on what is the end game, and you cannot really compromise on verifiability. But yeah, one way to do it is to have to Merkelize state for state commitments that can be used for like clients. So yeah, the question is, so we know that it's expensive, but there is a question on, is there anything we can do about it? And yes, there are ideas to improve Merkelization. And that's for me very, very interesting and important and good to know. That sometimes you think that blockchain technology is done or that we are late or many years passed and we still have to deliver on many applications. But I really insist sometimes on the fact that there are still important improvements to be made on the infrastructure side and on blockchain technology in general. And this is an example. So yeah, in this post, you will find different ideas and techniques on how to make this structure more efficient. And not all of them are new, but it's the combination that has been put together, put down in a very clear and nice way in this post that I think it's interesting. So yeah, I would invite you, and I will post a link, of course, in the sources. The first idea that was there was decoupling data storage format from the logical structure of the tree. So here you see the different, in this configuration, this is now a binary tree, and you have the node 1, the logical node 1 is actually stored on disk differently, node 1 physical, and it's explained why this becomes much more efficient on how to prove, for instance, inclusion, on how to write on this tree, and there are many other techniques also, how to use the drive more efficiently, depending on how that data is actually stored on the SSD. So it's for me, it's very nice to read. It's always nice to see improvement on the infrastructure side, and yeah, we are not anywhere done. That's my point. And it's important to be optimistic when we have these very nice improvements along the way. So yeah, that's all for today, and until next time, yeah, see you. Ciao.